This video will begin our discussion of section 6.5. This is just modeling with trig functions. They're going to give us a new name, a couple new names for our sine and cosine and tangent, all our trig functions. We're going to talk about periodic motion here. And another name that we give for our trig functions are sinusoidal. I think that's how you say it. That's how I've always said it. So these periodic motion functions or sinusoidal functions are like our sine and cosine functions. All they are is a very repetitive or a periodic function that just repeats. So what we're going to do, I'm going to do a couple reminders of these functions. We've done these in the past videos. So this should be a review for the first video, but these functions will follow the same format that we've been looking at. So these sinusoidal functions, typically they're giving more in this format with that omega, but this is the same format that we have been working at with in the past couple lessons, so it means the exact same thing. So let's review this first example. They want us to describe the motion or the transformation from sine to that function there. So first thing I'm going to do is rewrite this sine function, and remember we want this b to be out of our expression inside. So I'm going to factor a 4 out, and that's going to give me a pi over 8, and then plus 2. This 4 needs to be able to distribute back to get to our original expression. So, looking here, we pick up a couple things. We have our amplitude. Remember, that's the distance from the, for our sine and cosine functions, it's the distance from our midline up and down. So this amplitude is going to be 2. We can find our period. Our period is 2 pi over b, and our b in this case is the 4 there. So this is 2 pi over 4, which is pi over 2. So that's the period. So that's how long it's going to take to repeat itself. And it goes up and down 2 units above and below the midline. This is shifted to the right. That's that pi over 8. Remember, that has to be factored out like that. It's not the pi over 2 from the beginning. I also want to note that this pi over 2 did not come from there. That's not the same thing. It came from this definition, just to make sure that's clear. And then we go up to, that's the 2 at the very end. So that was the transformation. We could take our sine, if I were to move it right, pi over 8 up to, shrink the period down to pi over 2, and then make the amplitude go up and down 2, we would have that function there. Okay, we're going to graph one of these, only with amplitude and period shifts, not anything else. I wanted to erase these. Okay, so let's start with the amplitude is 2. Okay, so I know I'm going to go up and down 2, so I wrote that on my grid, Cartesian plane there. To find my period, remember we do 2 pi over b, and in this case, that's going to be 2 pi over 1 over 4. That was a number in front of x, or b. That is going to be 8 pi. So I know I'm going to start from 0 and go over 8 pi. Cut that in half to 4 pi, and then cut each one of those in half. So now I got 2 pi and 6 pi. And then my sine starts on the midline, and then I go up, back down to the midline, all the way down, and then to the midline. And then we connect. Yours probably is going to look much better than mine. There we go. So that is that graph. So what we're going to end up doing, I know I'm going kind of quick through these, but we have seen these before. It's just a reminder because we are actually about to put some harmonic motion and some applications to these functions, some more applications. All right, so the next one, what is the amplitude and period of that function? Okay, this is a quick pickup. Amplitude is 3, that's this number here. And then this is where we get our period. Remember, it's going to be for cosine, it's 2 pi over 3 pi. So that period is 2 over 3. So this cosine is going to take 2/3 of the time. Or not 2/3 of the time, it's really 2/3 of 2 pi of the time, whatever that is, what percentage that is. But it's going to take 2/3 of a unit to start repeating. We're not going to graph this, I think. I think that's a pretty good review for these functions, and hopefully you guys are just neck deep in this stuff right now, because this is practically the whole chapter is grading this. So we're going to, in the next 2 videos, we'll apply what we can to. Or harmonic motion. Bad sentence on my part. We're going to apply to harmonic motion and dampened harmonic motion.